Good morning, everybody. Today we're going to look at the review for Chapter 9 here. The first part of the review is solving rational equations. So we have x over 4 plus x over 3 equals 6, and that's going to be over 1. The idea is to give all of these a common denominator that include all the factors of our denominators. So in this case, 4, 3, and 1. So our LCD is going to be 12. That includes all of these factors. So I need to make that for each of these. So multiply the first one by 3, second one by 4, and the last one by 12. And that will give me a common denominator of 12 for all of them. 3x over 12 plus 4x over 12 equals 72 over 12. And at this point, so we got 3x plus 4x over 12, because it's a common denominator, equals 72 over 12. And at this point, you can ignore the denominators and solve the problem in the numerator. 3x plus 4x equals 72. So 7x equals 72. Divide by 7, x is equal to 72 over 7. I don't think that simplifies, because 7 is not a factor of 72. So we'll just leave it as a fraction like this. 72 over 7. Number 2, we have 2 over 5x minus 3 over 2x equals 2 over 1. Once again, we need a common denominator that has all the factors of our denominator. So factors 5, 2, x, 1. So we're looking at 10x here. 10x has all of these factors. So we'll multiply the first one by 2, that'll give us 10x. Multiply the second one by 5, that'll give us 10x. Multiply the last one by 10x. 4 over 10x minus 15 over 10x equals 20x over 10x. These can go into the numerator because they're the same denominator. So we get something like this. And then we can just solve the equation that's in the numerator. 4 minus 15 equals 20x. This is, so 4 minus 15, that's negative 11. Divide by 20, and we get our solution, negative 11 over 20. It looks like a lot of these are ending up as fractions, which is fine. As long as you can still check that they work in the problem, that they don't cause the denominator to be 0. The only solution that would cause our denominator to be 0 in this case is actually 0 itself. Number 3, we have 2 over x plus 1 minus 1 over x minus 1. And this is equal to 2 over x squared minus 1. Okay, so in order to figure out what factors we need in the denominator, we need to factor all of our denominator. The first one is fine, x minus 1 is the only factor, or x plus 1. The second one is fine, x minus 1 is the only factor. However, the last one, x squared minus 1, that can factor into two factors, x plus 1 and x minus 1. So we can see our LCD is going to need to include all of these factors. So it needs to include x plus 1. It also needs to include x minus 1. So we'll multiply each of these by whatever factor is missing. This one needs the x minus 1 factor. This one needs the x plus 1 factor. And this one is fine, it has all the factors it needs. So we'll distribute, that's 2x minus 2 over our LCD here, minus x plus 1 over our LCD equals 2 over our LCD. Now, when you combine these two into a single fraction on the left side, keep in mind both the x and the 1 are being subtracted. So when they get combined, and I gotta make this smaller because I'm out of room. When they get combined here into a single fraction, 2x minus 2, it's now minus x minus 1 over x plus 1 times x minus 1. And then 2 on the other side, also over our LCD. Now we can ignore the numerators or denominators. 2x minus 2 minus x minus 1 equals 2. And solve this equation right here. So combine like terms, 2x minus x is x. Negative 2 minus 1 is negative 3. Add 3 to both sides, and we get x is equal to 5. Make sure that this does not cause your denominators to be 0, okay? We can't have solutions that cause our denominators to be 0. This one's fine. 5 plus 1 is 6, 5 minus 1 is 4, 5 squared minus 1 is 24. All of those are fine, so this works as a valid solution. Number 4, we have 5 over x plus 3 minus 2 over x squared plus 4x plus 3, and that's equal to 6 over x plus 1. Okay, once again, we need to factor our denominators, so x plus 3, that's just its own factor. X squared plus 4x plus 3, that factors into x plus 3 and x plus 1. On the other side, we have 6, and that's over x plus 1. So our LCD needs to include all of these factors, so x plus 3 and x plus 1. So we're going to have to multiply by whatever factor we're missing. So we'll multiply this one by x plus 1. This one's fine. We'll multiply this one by x plus 3. All right, so 5x plus 5 over our LCD minus 2 over our LCD equals 6x plus 18 over our LCD. These can be combined into a single fraction with a common denominator, or you can just go ahead and start setting up the equation, but it would be 5x plus 5 minus 2, and it's over a single denominator. On the other side, 6x plus 18, also over our common denominator. And now we can set both sides equal to each other and solve the equation. So 5x plus 5 minus 2 equals 6x plus 18. Combine like terms, so 5 and negative 2 is positive 3. Move the x's to one side, so I'm going to move them to the left side, so minus 6x. So negative x plus 3 equals 18. Move the constants to the other side, so subtract 3. Negative x is equal to 15. Divide by negative 1. X is equal to negative 15. Make sure to check that this is a valid solution. All right. The only solutions we were trying to avoid here were negative 3 because of this one and negative 1 because of this one. So negative 15 is totally fine as a valid solution. Now we've got some work rate problems. These are real-life modeling problems for rational equations here. So you can set these all up as rates. So Marlene can wash 35 dogs in 3 hours. Trenton can wash 55 dogs in 6 hours. Working together, so adding them together, how long will it take them to wash 80 dogs? So 80 dogs in some X hours. So this would be our rational equation. And then we can solve this rational equation for the denominator x to see what our solution should be by multiplying them all to give them a common denominator. In this case, 6x would be fine as a common denominator. So I'll multiply this one by 2x, I'll multiply this one by x, and I'll multiply this one by 6. Gives us 70x over 6x plus 55x over 6x equals 80 times 6, whatever that is, 480 over 6x. So now we can just solve the equation in the numerator. 70x plus 55x equals 480. So 70 plus 55. So 125x equals 480. Divide by 125. And I think we're supposed to round to the nearest hundredths place, is what it said. Yeah. So the number of hours is going to take about 3.84 hours for them to watch 80 dogs. All right, 80 dogs in 3.84 hours. Number 6, Marco can paint the kitchen in 7 hours, so 1 kitchen in 7 hours. Ted can paint it in 9 hours, so 1 kitchen in 9 hours. Shane can paint it in 4 hours, so 1 kitchen in 4 hours. How long would it take to paint the kitchen if they work together? So 1 kitchen in X hours. When you add all these rates together, you get 1 kitchen painted in X amount of hours. So I can do a common denominator here that needs to include all of these factors, 7, 9, and 4. And I'm actually not sure what number includes all of those factors. So I'm just going to multiply them by each other. I'm going to say that my LCD includes all those factors, 7 times 9 times 4 times x. So that's 252x is what I'm going to use here. There might be a smaller one, but I don't think there is, because they don't have any factors in common. Yeah, they don't have any factors in common, so I would just have to use all of the factors. So this gets multiplied by 36x, because it gets multiplied by 9 and 4 and x. This gets multiplied by 28x, because it gets multiplied by 7 and 4 and x. This gets multiplied by 63x, because it gets multiplied by 7 and 9 and x. And this one gets multiplied by 252. So 36x over 252x plus 28x over 252x plus 63x over 252x equals 252 over 252x. So all our denominators are the same, so we can just kind of ignore them. So 36x plus 28x plus 63x equals 252. 36 plus 28 plus 63. So 127x equals 252. Divide by 127. And it says round to the nearest hundredths place, so about 1.98 hours is how long it would take them to paint the kitchen together. Seems kind of, well, it's almost 2 hours, so I mean, that seems okay, I guess. Yeah, it's almost 2 hours, and there's 3 of them painting together, so yeah, that makes sense. Number 7 and 8, we are simplifying and stating any restrictions on the variable. Okay, so in order to simplify, we are factoring. So we factor out the 4 here to get x minus 2. and then x squared plus x minus 6 is x plus 3 and x minus 2. X squared plus 3x is x and x plus 3. Now, since this is multiplication, all the factors in the top and bottom are just included as factors of the top and bottom. So we can just cancel out factors that are included the top and bottom. So x plus 3 can cancel, x minus 2 can cancel, and we are left with 3 over 4x as our simplified product here. Now, we do need to state the restrictions. So the restrictions are going to come from all the denominators here, okay? So none of our denominators can be equal to 0. So in this case, if we look at the factors x minus 2, x cannot be 2 because 2 minus 2 is 0. The factor x cannot be 0 because 0 is 0. And the factor x plus 3, x cannot be negative 3 because negative 3 plus 3 is 0. So these are the restrictions on this problem here. X cannot be equal to any of these values. Okay, number 8 is division, which means we flip the second fraction so that it becomes multiplication. X squared minus 8x plus 15, that's x minus 3 and x minus 5. X squared minus 7x plus 12, that's x minus 3 and x minus 4. The second fraction I'm flipping, so I'm flipping these, so I'm going to factor the numerator. So 3x comes out on the 3x squared minus 12x, leaving us with x minus 4. And then since I flipped it, the numerator is now the denominator. So x squared minus 13x minus 40, that's x minus 5 and x minus 8. I can go through and cancel out all of the common ones. So I have x minus 3, x minus 4, x minus 5. So the simplified version here, 3x over x minus 8. Now the restrictions of a division problem are a little bit different because if you look at a division problem, the denominators cannot be equal to 0, but also you're dividing by this entire fraction. So this numerator can't be 0 either. So you actually can't have anything causing this, or this to be 0. The only thing that could possibly be 0 is this right here. So we actually need to get our restrictions from all three of these. So from this one, we know that x cannot be 3 and cannot be 4, because 3 minus 3 and 4 minus 4. For this one, we know that x cannot be 5 and x cannot be 8. And then for this one, we know that x cannot be 0 and it can't be 4. We already have 4, so that's fine. Okay, so this is one that we didn't really talk about that much. However, it should make sense because we're dividing by a number here, and this number cannot be 0, which means that the numerator of this can't be 0 either. Okay, identify the key features of the graph and describe the transformations. Okay, so from 1 over x, so this is 5 over x minus 2 plus 3. The transformations, this is to the right by 2, because our a is 5, our h is 2, our k is 3. So this is to the right 2, up 3, and it's been stretched vertically by a factor of 5. So the vertical asymptote is going to be at x equals 2. Horizontal asymptote is y equals 3. Let me put those on my graph. Now I'm just going to do a quick sketch. I'm not going to use a table. because it doesn't specifically ask me for a table. I know what this looks like, so I'm not going to use a table here. So x equals 2, y equals 3, and we know that it looks something like this. As far as my range is my domain is everything except for 2, the vertical asymptote. My range is everything except for 3, which is my horizontal asymptote. My x-intercept, you can find your x-intercept by plugging in 0 for y, and you can find your y-intercept by plugging in 0 for x. So let me do the y-intercept first. So I'm going to plug in 0 for x. So 5 over -2 plus 3. -5 halves plus 3, which is 0.5, 0.5 or 1/2. So my y-intercept, plugging in 0 gives me 0.5, and that's like right here. So I kind of didn't graph it correctly because it's supposed to be right here. So maybe I should fix that a little bit. Yeah, I don't know. It looked better before, I guess. And then my y-intercept, I can find my y-intercept by plugging in 0 for, or my x-intercept by plugging in 0 for y. So I have 0 equals 5 over x minus 2 plus 3. I can solve this by subtracting 3. -3 equals 5 over x minus 2. You can multiply both sides by x minus 2, or just give them a common denominator of x minus 2. So I get -3x plus 6 equals 5. And I can solve this for x here. So -3x equals -1. And x is equal to 1/3. So the y-intercept is 1/3, or 0.3 comma 0. Oh, whoops! I actually had my y-intercept here. My x-intercept is right here. They're actually pretty close to each other. So 0 and 0.5, which is right here, and my x-intercept, which is 1/3, and 0, which is right here. So this would be pretty good for number 9. This is totally fine. Okay, I believe we left off here on number 10, graphing 3x plus 12 over x squared plus 5x plus 4. This one does require us to factor it, so we will factor out the 3, x plus 4, and this factors into x plus 4 and x plus 1. So the simplified form, the x plus 4s are going to cancel here. We have 3 over x plus 1. Okay, so we got a couple of transformations here based on the parent function. Transformations that we have a stretch, vertical stretch by a factor of 3. We also have a shift, because the a value is 3 here, the h value is -1, and the k value is 0. So we also have a shift left by 1. Okay, and just like before, I am just going to make a quick sketch here. I'm not going to do the actual points. So my vertical asymptote will be at my h value, so x equals -1. My horizontal asymptote will be at my k value, so y equals 0. So I can put these on my graph here. X equals -1 right here. Y equals 0, that's right here. And I know what this looks like. It's going to be something like this on the right side, and something like this on the left side. And I'm trying to think back to the previous problem. I don't know if I did the whole of the previous problem. I assume that I did because I have it right there. So, okay, so I do my x and y intercepts by setting these equal to 0. So my x-intercept, or I'll start with my y-intercept. So setting x equal to 0. So 3 over 0 plus 1. So when you plug in 0, you get 3. So 0, comma 3, which is like right here. So we can see our x, sorry, not right there. That's my, my y-intercept. 0, comma 3, which is like right there, my y-intercept. And then my x-intercept I can find by plugging in 0 for y. So I'll set the equation itself equal to 0. So 3 over x plus 1. And this isn't going to work. You multiply by x plus 1, but 0 times x plus 1 is just 0. You get 0 equals 3. It doesn't even make sense. And that's because there is no x-intercept, because that's where the asymptote is. So there's no x-intercept. Let's take a look at where the holes are. There's actually going to be a hole at -4, because that is where we crossed off the factor x plus 4. Okay, so x plus 4 makes the original denominator equal to 0. So we cross that factor off, but it still makes the denominator equal to 0, so it's still undefined value. So we're going to plug -4 into our equation to see where that is. And what we get is 3 over -3, or in other words, -1. So our hole is at -4, -1. So I'm going to go to -4, -1, and I'm going to put a hole there. There's a hole right here at -4, -1. And I actually don't know if I did the hole in the previous problem. So now that I'm thinking, I did it a couple of hours ago, so I'm trying to remember. I don't remember doing the hole in the previous problem, but there's the hole for this one, -4, -1. Our domain is, maybe I didn't even finish the problem because I'm not remembering doing this in the previous problem, so maybe I didn't finish it. Our domain is everything except for the asymptote and the hole. So x cannot be -1, and x can also not be -4, because that's where the hole is and that's where the asymptote is. Those are the values that make the denominator equal to 0. Our range is everything except for, once again, the hole and the asymptote. So y can't be 0, y also can't be -1, because that's where the hole is, right here. All right, moving on to number 11, which is the last one. Number 11 says, state the restrictions on the domain for this function. Okay, this is easy enough. The restrictions on the domain are whatever values of x we can't use, which is whatever values of x make the denominator equal to 0. So I just need to factor this to figure out what that is. I don't even need to factor the numerator because that doesn't even matter. All that matters here is the denominator, because I can't use x values that make the denominator equal to 0. So x squared plus 2x minus 24, that factors into x plus 6 and also x minus 4. Which means that the restrictions for the domain are that x cannot be equal to -6 and x can't be equal to 4, because that causes this to equal 0, which is not even, no, it doesn't cause it to equal 0. It makes it undefined, which is not allowed. So these are the restricted values of the domain. We're not allowed to use those for our x value. All right, and that's it for the review. Hope you all learned something.